Hello and welcome to Unit 6, Day 2. We're going to be talking about similar polygons in this video. So we're going to start off by talking about some terminology on what it means for polygons to be similar. Similar polygons are polygons with the same shape but different sizes. Same shape but different sizes make them similar. Okay? And there's some characteristics for polygons to be similar. First, polygons are similar if corresponding angles are congruent and second, if corresponding sides are proportional. You'll remember that we spent the first lesson in this unit talking about solving proportions, and so that's where this is going to come into play. Now, I'd also like for you to understand that the ratio of corresponding sides is called scale factor. And secondly, if polygons are similar, then, sorry, it's the word then, their perimeters are proportional as well. Okay? All right, and that leads us to talking about scale factor. In order to do some information with scale factor and to work on explaining what that is, you need to draw these two triangles on your page. First, draw triangle ABC like I've drawn, and then triangle DEF, where DEF is a little bit bigger, but it still looks the same shape as ABC. So that we can mark angles A and D congruent, angles B and E are congruent to each other, and angles C and F are congruent to each other. So mark them like that. And then I'm going to give you some numbers to write in for the lengths of all 6 sides. AB is 8, BC is 10, AC is 18, and for the other triangle, DE is 12, EF is 15, and DF is 27. And that's going to help us find that proportion, that relationship of the sides of this triangle compared to its similar triangle, DEF. So pause the video if you need to copy that down still. Otherwise, we will go ahead and take a look at scale factor. All right, the first thing I want you to understand about scale factor is that order matters. So the order of our ratios is important. We're either going to go smaller to larger, or larger back to smaller. That order changes your scale factor. Okay, we will write scale factors as ratios. Okay, the ratio of corresponding sides is called our scale factor, so we write those as fractions. And so, first, we can talk about the scale factor of triangle ABC to triangle DEF. So we want to compare those sides. And so I'm just going to pick out some corresponding sides. AB, angle A is congruent to angle D, B is congruent to angle E. So side AB would correspond to side DE. So we can say that the scale factor is 8 to 12. But we always want to reduce that, and we get that that simplifies to 2/3. So the scale factor of ABC to DEF is 2 to 3. But if I compare scale factor of DEF, triangle DEF, to triangle ABC, then it turns it around. And we go from 12 to 8, which takes the reciprocal of our fraction, makes it 3/2. So you have to pay attention to what order you're given in a problem so that you make sure you have the order of your ratio set up correct. Okay? All right, and then I do want to ask a third question here. What is the ratio of the perimeter of triangle DEF to triangle ABC? Now, we can add these sides up and get that the perimeters, what they are, so to find that. But you can also remember this. If polygons are similar, then their perimeters are also proportional. So I want you to notice what the ratio ends up being. Okay? So if we look at the individual perimeters, if I add up 12, 27, and 15 for triangle DEF, I get a perimeter of 54. And for triangle ABC, if I add up 8, 18, and 10, I get 36. So I can start with that and say the perimeter ratio is 54 to 36. And then I can reduce that. But when I reduce it, I get a 3 to 2 ratio. Okay? We can divide these both by 18, is the greatest factor you can divide by. And you get 3/2, which is the same as the scale factor of DEF to ABC. And so you'll notice that the perimeter ratio is also the same as the scale factor ratio. All right, and this leads us to being able to talk about similarity statements. And so first I want you to understand what the symbol for similarity is. Okay? The symbol for similarity is that tilde symbol, which is like the top of the congruent symbol. And so this is what tells us that they're the same shape, but not necessarily the same size. And so when we talk about making a similarity statement, it's important to understand this. A valid similarity statement, and I'm abbreviating, must match corresponding, I'll abbreviate, angles and sides. Just like in a previous unit we talked about a congruency statement had to have matching corresponding angles and sides, so does a similarity statement. So what I'd like us to do is to write a similarity statement for triangles ABC and DEF that we were using above. Okay? Well, triangle ABC matches up to triangle DEF, not just because it's alphabetical order, but because we've marked angle A and D congruent, angle B and E congruent, and angle C and F congruent. So we can say that triangle ABC is similar to triangle DEF. And if I change the order of any of these letters, I have to change the order of these other letters to match. All right, we're going to go ahead and take a look at some examples now. And so in our first example, what I want us to do is to fill out this chart by listing the pairs of corresponding angles that are congruent and listing out the proportionality of the sides. And so that's what we're going to do for these two triangles. Now we are given that triangle JKL is similar to triangle PMN. That means that angle J has to be congruent to angle P because they come first in both labels. So we can say angle J is angle P. We can say that angle K is congruent to angle M. And we can say that angle L is congruent to angle N. Okay, and that's similar to what we did when we talked about congruent triangles. Well, now we're going to list the sides differently. We don't have sides that are congruent, but they are proportional. And so what I'm going to do is match up corresponding sides in ratios. So the ratio of side JK to its corresponding side PM, JK goes with PM, so I'm going to write that like this. That ratio of JK over PM has to be the same as the ratio of KL over MN which must be the same as JL over PN. Now if you look at that, notice the tops of all of these come from our first triangle, JK, KL, and JL. And the bottoms all come from our second triangle. If that's the order the similarity statement is given in, that's the order you need to stick with here. I can't mix and match these. I can't start with JK over PM and switch this fraction around. Now I can change the order that I list the ratios, but the tops must all be from the same triangle and the bottoms must all be from the other triangle. Okay, we're going to move on to another example. In these problems, we are given two figures with some information, but they also give you the scale factor. So if you need to pause the video to copy this down, go ahead. Okay, once you have that all copied down, including the pictures, we should be ready to work out the problem. We are given a scale factor of 2 to 3. That means the ratio of a measurement here to its corresponding measurement here is in a 2 to 3 relationship. To be able to find the value of x, well, we're just going to be using proportions. Remember, the side lengths should be proportional. Remember, a proportion is a set of two equal ratios. So this ratio of 42 to x, okay, we know that it has to follow that x would be the larger one because it's given in the longer side here, has to be in a 2 to 3 relationship. Okay, and so to solve this, again, remember we solve proportions by cross multiplying. 3 times 42 is 126. And then we divide by 2. And we get that x equals 63. Okay? And so we can use similar figures to set up proportions and solve problems. All right, and those are the only examples that we're going to cover in the video. We didn't go through a lot of examples. We will do more examples in class, so make sure you bring your notes with you completed and filled out, so we can do some additional examples in class. But otherwise, be ready to go, and we will work on this assignment in class also.